In this video, we're going to be discussing about the basics on cholinergic pharmacology. I have already made a video on an introduction to the autonomic nervous system pharmacology. Please watch that video also to get a better understanding on the topic. Please subscribe to my channel to get regular updates on the videos that I post. The cholinergic system is a part of the autonomic nervous system in the body. Its activation produces a rest and digest response. The main neurotransmitter in the parasympathetic nervous system is the acetylcholine, and that's why the system is called the cholinergic system. The major receptors in the cholinergic system are the muscarinic and the nicotinic receptors, and the acetylcholine binds to these receptors and triggers responses. Now let's discuss in detail about the cholinergic neurotransmission. The choline molecules that are found outside the neurons are taken up inside with the help of a transporter called the sodium choline cotransporter. This choline is then combined with acetyl coenzyme A with the help of an enzyme called choline acetyltransferase to form acetylcholine. The formed acetylcholine is then stored inside vesicles. This can help prevent its degradation. During an event of action potential at the neuron, the calcium channels are opened and influx of calcium inside the neuron happens. This leads to the release of the stored acetylcholine into the synapse. The acetylcholine so released can bind to the muscarinic and nicotinic receptors and produce responses. The binding of the acetylcholine to the presynaptic receptors, also known as autoreceptors, help to prevent the release of more acetylcholine into the synapse. The acetylcholine in the synapse is then broken down by the enzyme acetylcholinesterase to form acetate and choline. The formed choline is used again in the cycle. The muscarinic receptors, as the name suggests, have a very high affinity to a compound called muscarine. The muscarinic receptors are mainly of 5 types: the M1, M2, M3, M4, and M5 receptors. Among them, the M1, M2, and M3 are the most important ones. These are G protein coupled receptors, and among them, the M1 and M3 receptors are GQ type, and the M2 receptors are GI type. The GQ type receptors, that is the M1 and M3 receptors, when activated by acetylcholine, causes an influx of calcium inside the cells where they are present and produces depolarization or simply an excitatory effect. The GI type receptors, that is the M2 receptors, when activated by acetylcholine, causes an opening of the potassium channels which produces hyperpolarization, or simply we can say an inhibitory effect. The M1 receptors are mainly found in the gastric glands, salivary glands, and in the CNS. Its activation causes increased gastric acid secretion. It also aids in functions such as memory, attention, etc. The M2 receptors are found in the heart, and its activation causes a reduced heart rate, slowed AV node conduction, and a reduced force of contraction. The M3 receptors are found in the smooth muscles of organs such as the digestive tract, bronchiole, eyes, bladder, etc. They are also found in several exocrine glands in the body, such as the salivary glands, the lacrimal glands, etc. Its activation causes contraction of the smooth muscles and glandular secretion. The nicotinic receptors exhibit a high affinity to a compound called the nicotine. They are of 2 types, the NN and the NM receptors. Both the NN and NM receptors are ligand-gated ion channels. The binding of acetylcholine will cause an influx of sodium into the cells, which leads to depolarization or simply an excitatory effect. The NM receptors are found in the neuromuscular end plates. Its activation causes muscle contraction. The NN receptors are found in the autonomic ganglia, and its activation leads to the transmission of impulses from the preganglionic fiber to the postganglionic fiber. If you like this video, please hit the like and share button and subscribe to my channel. Thank you for watching.